Okay, this is the final video in the hydraulic jump lecture. The purpose of this video is to introduce you guys to the experimental apparatus that you'll be using, and to describe, how to use it and how to read the various data that you'll need to read in order to calculate the correct radius of the jump. So I've got it set up and running. You guys may encounter it running, or you might encounter it shut off and you'll have to start it up. But essentially it just consists of a column of water. So this is our water reservoir. Here is an adjustable nozzle, and then a catchment basin that provides both the target for the hydraulic jump and just another water basin where the water is collected. The water then moves through this valving system here into a pump, and the pump speed is controlled by this speed controller, and this rotometer gives you the volume flow rate of the fluid running through the system. And then I'll follow this Tygon tube all the way back up, and it's essentially a closed loop system that just deposits the water back into the water column. So that's essentially what we're dealing with in terms of the experimental apparatus. Now, what you guys will do when you encounter the apparatus, you'll need to set a unique volume flow rate that will make your experiment unique from everybody else. And so you will adjust this blue handle here on the nozzle, and that will change the rate of fluid flow. So let me do that right now. So let me turn it clockwise, and that will turn it off. And you can see as I turn it off, the volume flow rate decreases and the radius of the hydraulic jump goes down. And if I turn it the other way, counterclockwise, I'm now increasing the volume flow rate. Whoop. There we go. Increasing the volume flow rate, and that's causing the jump radius to increase. So you guys will come up with a unique setting for that flow of water out of the nozzle, and that will create a unique radius for the hydraulic jump, which you guys will eventually measure. The next step then is to make sure that the system is operating in steady state. So we want to make sure that the rate at which the water is coming out of this nozzle is identical to the rate at which the pump is returning water to the reservoir. And so what we're going to do is look up here at the reservoir. The reservoir is a graduated cylinder, and we're going to check the water level to see what's happening. And I'm not sure if you can see it in the video, but what's happening is the water level is very slowly dropping. You can see the water level dropping there over the span of several seconds. So what that means is that the pump is not pumping the water fast enough to maintain steady state. So we're actually losing water in the reservoir. So we need to increase the velocity of the pump until that water level stays fixed. So I'm going to go over here. I'm going to just use this speed controller. I'm going to just kind of keep an eye on the volume flow rate. So what I'm going to do is turn this guy, and you guys will see, whoop, the volume flow rate dropped. I don't want that because I'm already losing water. So let's turn this guy the other way, and the volume flow rate will go up. And as I'm doing this, I'm also looking up here at the water column. You'll notice now the water column is increasing, and it's increasing pretty quickly. So I've now got the pump pumping too fast. So I want to bring the volume flow rate down, and we'll take a look back up here and see what's happening. So that actually looks pretty good, right? The water level's falling just ever so slightly. So I need to increase the pump volume flow rate just a little bit. So let's, that's decreased. Okay, that's increased. Then we'll go back up here and check. And the water is now increasing just ever so slightly, so we got to bring this down just a tad bit. There we go. Okay, that seems pretty good. So you guys are going to want to just iterate back and forth a few times. Once you've set the volume flow rate here, you're going to want to change the pump speed to make sure that the water column is at a fixed height. And then you're going to want to just iterate back and forth between checking the pump speed and checking the water column height to make sure that your system is in steady state, that you've selected the pump speed correctly to keep things in steady state. So once we've got that set, we're now ready to take an experimental measurement. So I'm going to come in here. There's, remember, 4 things that I need to measure. The first is the volume flow rate. And so I'm going to look here at this rotometer. And what I want to do is read from the top of this little bobber, this little float that's kind of moving very slightly up and down there. So I want to read in liters per minute because I'm in the metric system and it's easier to convert when you're in the metric system. So it's reading, somewhere between about 1.25 and about 1.5 liters per minute. So I would say something like 1.4 liters per minute, maybe plus or minus 0.1 or 0.15 liters per minute. It's up to you guys to decide, as the engineer is running the experiment, what this experimental value actually is and what the uncertainty in the measurement is. So I'll leave that up to you guys. But I'm, again, reading something about 1.4 plus or minus 0.15 liters per minute with the rotometer. Okay, so that's one value. That's the value of Q. The other couple values that I need the value of the diameter of the nozzle, which we'll measure at the end. And then I also need the height of the hydraulic jump, and I need the radius of the hydraulic jump to compare everything against. So what I'm going to do is I'll set this guy. I'm going to set him right like that. Yep. See if I can get it to focus. There we go. Okay, so I'm going to set them right like that. I'm going to show you guys how to measure both the radius and the height of the hydraulic jump. So for the radius of the hydraulic jump, I'm just going to use a set of calipers. So here are my calipers. I'm going to open up the jaws, and I'm going to very carefully bring the jaws down like so, just so that I'm just barely touching the surface of the water. Just barely. So just about that. Now this is not an exact science, not an exact measurement. We are going to take into account the experimental uncertainty here, but you can see this is pretty darn close to the diameter of the hydraulic jump. I'll take half of it and that'll give me the radius. And I want to be sure not to, accidentally touch the water as I'm doing this. So, I don't want to stick this thing in the water or stick it in the water like this, because that, obviously messes up the hydraulic jump, and then it takes a little while to reset. But, it will reset and we get back to the same diameter. So that's fine. So I've got that value. Let me show you here. That value is 40.2 millimeters. So that's how I get the diameter of the hydraulic jump. I'll divide it by 2 to get the radius. And then to measure the height of the hydraulic jump, I've devised this pretty clever system where I'm going to use just a drinking straw like this. I'll show it over here. A drinking straw. And I'm going to cover the drinking straw with some water-soluble paint. So you guys will see this step in the lab. So here's the drinking straw with the water-soluble paint on it. So I'm just going to kind of rub the water-soluble paint all over the straw, like so. Okay, so it's pretty nicely coated, pretty well coated now. And then something pretty interesting happens when I stick the straw into the flow. So here I'll stick it into the flow. See if we can focus on it there. You can see the paint actually washes away, and what I'm left with is a little band of essentially clear straw area, and that band represents the height of the hydraulic jump. So I'm going to take my same dial caliper here, and whoops, oh no. Okay, didn't wash off too badly. I'm going to take my same caliper here, and again, this isn't rocket science, but I'm going to just measure the height. Whoops, let me get in the frame here. There we go. I'm going to measure the height of that band, like so, from the bottom of the straw, right? Because the bottom of the straw was at the bottom of the water, and this band was formed at the top of the water. So that gives me now the height of the hydraulic jump. So you can see it's 5.2 millimeters. So that is my my radius measurement and my height measurement. And now I need to measure the diameter of this nozzle. So what I'm going to do is shut off the pump. So the pump is now shut off. I'm still just using that reservoir of fluid, but I'm going to shut this off too. And I'm going to come in here with my caliper, and I'm going to just put it right there. And I'm going to get a diameter which is about 2 millimeters. So that's the diameter of the nozzle. Okay, so let me pull this out here. So that now gives me all of my measurements. I've got the volume flow rate from the rotometer. I've got the diameter, which is also the radius of the hydraulic jump from the dial caliper. I got the diameter of the nozzle from the caliper, and I got the height of the hydraulic jump by using that straw. So I've got a little bit of a leak here because the fluid is running over. So I'm going to close out this video, clean up my mess, and call it a day. But this is the last video in the lecture for hydraulic jump experiment. So thank you for your attention, and I will see you guys in the lab. Bye.